Welcome back. This is the third lesson recording for IM1, May 21st, 2021. So this is Desmos card number 1. This is the most important thing. Pythagorean theorem only applies to this type of triangle. Which ones? Does it have to be acute triangle, right triangle, or obtuse triangle? That's right, it has to be right triangle. It needs to have that 90 degrees. Okay, yes, there must be a right angle in the triangle for the Pythagorean theorem to be true. It only applies to right triangle, never to any other triangles. Which of these sides is hypotenuse? Is it the green side, red side, or the blue side? Okay, so how do we know which is the hypotenuse? See the 90 degree? Okay, its hypotenuse is going to be always across from, opposite the 90 degree symbol, so it's the green one. The red and the blue are right next to the 90 degrees, adjacent to it, so they are the legs, and the green is the hypotenuse. Which equation below is correct interpretation of Pythagorean theorem for the right triangle pictured on the left? Remember, the hypotenuse is always the longest side of the right triangle. Okay, so first thing is, which is the right triangle? Which is the hypotenuse? Well, 90 degrees, identify the 90 degrees, and from there, go across from it. Okay, you're always going to have the 90 degree symbol and go across from this 90 degrees, and that's going to be the hypotenuse. So if y is the hypotenuse, then the other ones are the legs. So it's going to be leg 1 is x1, x, and leg 2 is z. So it's going to be x squared plus z squared is equal to hypotenuse squared, which is y squared. So y squared is the hypotenuse. It's going to be this one. Okay, which is the correct Pythagorean theorem equation for this right triangle? Okay, so if x is the variable that is on the hypotenuse, and I know that because it's across from the right angle symbol. Okay, so it's going to be leg 1 squared plus leg 2 squared is equal to hypotenuse squared. So it's 9 squared plus 12 squared is equal to x squared. 9 squared plus 12 squared is equal to x squared. You could have said 12 squared plus 9 squared is equal to x squared as well. That it doesn't matter. Using the correct equation from the previous screen, solve for the value of x. So previous screen we said the correct equation was 9 squared plus 12 squared is equal to x squared. Okay, now again, what do we do first? Do we do exponents first or do we add the numbers first? Exponents are always before adding and subtracting. So we need to evaluate 9 squared and 12 squared first. What's 9 squared? That's 81. What's 12 squared? That's 144. Equals x squared. Okay, notice that I am going line by line. What is 81 plus 144? 1 plus 4 is 5. 8 plus 4 is 12. So it's going to be 225 is equal to x squared. Okay. Now, what do I do now? I don't want x squared. I want x. So I need to undo squaring. How do I undo squaring? What is the opposite of squaring? It is square rooting. So you take a square root of both sides. When I do that, square and square root symbol, they cancel each other out because they undo each other. And you're just left with x on the right hand side is equal to, you use the square root symbol on your calculator and you should get 15 as your final answer. So then you enter 15 right here and then check my answer, and yes. All right, now which triangle side is the hypotenuse this time? Okay, now right now the triangles are rotated. Again, the easiest way is to identify your right angle and then go across from it. Okay, so green is my hypotenuse. Hypotenuse is always the longer side as well. But sometimes, when the legs are very, very long, sometimes it might be a little more difficult to tell. But this way, identifying the right angle and then going across from it is always going to work. All right, which is the correct Pythagorean theorem equation for the right triangle here? Okay, so x is across from the right angle, so that's the hypotenuse. So this is a leg, this is another leg. So it's going to can be 5 squared plus 7 squared is x squared. Okay, so that's going to be the first option for me. Now solve for x in the diagram. Okay, so previously we said the correct equation was 5 squared plus 7 squared is equal to x squared. Why? Because this is my hypotenuse. This is my leg. And this is another leg. Okay, so then from here, I need to evaluate the square exponents. 5 squared is 25. 7 squared is 49. That is equal to x squared. 25 plus 49. 5 plus 9 is 14. 2 plus 4 is 6. 6 plus 1 is 74 is equal to x squared. So now I have x squared is equal to 74. Now that I have a number, just a number, I can take a square root of both sides. And squaring and square rooting, the symbols cancel out because they undo each other. X is equal to square root of 74. So I want you to pull out your calculator and then evaluate this. Okay, so square root of 74 is 8.6, 8.60. So I am going to enter that as my answer. Okay, great. Moving on. Okay, which is the correct Pythagorean theorem equation for this right triangle? Which is your hypotenuse? Again, 16 is the hypotenuse. Okay, and that is referring to this length. So this length is x, this length is 9. So it's going to be x squared plus 9 squared is equal to 16 squared. Okay, just the variable x does not always have to be on the hypotenuse. It can be anywhere. It could be the unknown. It could be the leg length that we do not know. So therefore, in this case, it's going to be x squared plus 9 squared. X squared plus 9 squared, or 9 squared plus x squared is 16 squared. It's this one. All right, so on a separate sheet of paper, set up the equation using the Pythagorean theorem and use it to solve for the value of x. Actually, it should be saying x, not y. Enter your answer below and check your work. Okay, so I am going to say, what is my equation going to be? I can do, this will be a leg, and this will be another leg, and this is the hypotenuse. So it's going to be x squared plus 9 squared is equal to 16 squared. So then what do? Okay, I want to evaluate the expressions, simplify it to numbers as much as possible. I know that 9 squared is 81, so I have x squared plus 81 is equal to 16 squared, and that is 256. So then what do? Okay, remember when you had 2x plus some number is equal to 256, to figure out what value of x is, we need to undo, we need to go backwards. When we're going backwards, we add and subtract first. So we are going to subtract 81 from both sides. When I do that, that becomes 0, and you are left with x squared on the left-hand side, and 6 minus 1 is 5, 15 minus 8 is 7, so 175. Now from here, I don't want x squared, I want x, so I'm going to take a square root of both sides to cancel out the squaring, and you're left with x is equal to 175. Use your calculator, okay? Use your calculator to find square root of 175, and that is going to be 13.22. or 13.23. Okay, so I can enter that here. Okay, all right, and that's it for now. So hopefully now you see that for any right triangle, and it has to be a right triangle, the following is true, that leg squared, leg 1 squared plus leg 2 squared is hypotenuse squared. And that's what Pythagorean theorem is. And visually, this leg square means a square with the length of the leg 1. And leg 2 square means it's the square with the length of leg 2. So it's going to be leg 2 here and leg 2 here. It's the area of the square with that as a length is going to be equal to hypotenuse squared. So if the hypotenuse is the length, if I create a square there, the area of this green triangle, green square, and the pink square is going to be equal to the blue square. So visually, what that means is, look at that, that if I just take away the edges like that, then the green square, area of the green square plus the pink square is the blue square. That's what it says. All right, so then you are going to be working on card number 11 to 22 of Desmos, and you're looking at Pythagorean theorem, Pythagorean in coordinate plane. You're going to extend that onto the coordinate plane, and like meet Mr. Happy. He gets grumpy when he doesn't know the distance he'll be traveling. Move to the next screen to help him. Okay, so now guess the numeric distance Mr. Grumpy travels from point J to K. What do you think? I don't know. So this is just going to be a wild guess. Maybe it's 3, maybe it's 5, maybe it's 25. I don't know. And you can explain. Well, I really don't know because there is no reference as to what that length is. Okay, what if we have a little more information by, okay, so we've measured the width of his face and therefore we said that's 1 unit. Okay, so then we can, does that help us gauge how far J is from K? Well, I can say, okay, that's 1, maybe 2, 3, 4, 5, 6, maybe 6 units. I'm not sure, but I'm eyeballing it. Okay, so this is where I'm just eyeballing it using that as the unit. So it's not going to be all that accurate, but that is at least better than just having a wild guess. All right, now we're given the grid. Is that more helpful? Oh yeah, because now I know that this is 1 unit. I just need to count the squares. So 1, 2, 3, 4, 5, 6, 7, 8. JK is 8 units. Now, knowing that JK is 8 units, so from here to there is 8 units, estimate the distance Mr. Grumpy travels from point J to L. From here to there, it is definitely smaller than L because it is shorter, okay? It is shorter. Maybe it's about this length, this long. So maybe my guess is maybe 6. Okay, that's my guess, okay? If necessary, refine your estimate now that Mr. Grumpy gave us more information. So I know that this length is equivalent to 1. Then I can say 2, 3, 4, 5. I'm going to guess 5. Okay, no, it turns out it was actually 6 units. 1, 2, 3, 4, 5, 6. So even just having that reference was not as helpful, but having the grid is really, really helpful, isn't it? Okay, now let's compare the point here. Okay, so now we're trying to estimate this length. Select the statement that you agree with below. Okay, what do you notice? Well, this is a right angle triangle. So this is going to be hypotenuse. That means this is going to be the longer side. So LK is going to be longer than JK. LK is longer than JK.